In order to solve this problem, like any other physics problem, we need to set up our coordinate system. In this case, I'm going to let this direction be the C direction. This one is going to be Y, and this one is going to be X. That means that this P1, that for now we're going to locate at its center, is going to be pointing in the Z hat direction. So we can write P1 is going to be P Z hat. And this other vector, this other dipole, is going to be pointing in the Y direction, P2. So P2 is going to be Py hat. Now they ask us to find the the torque at its center of each dipole. But in order to find the torque, first we need to find the electric field. So remember that the torque is going to be equal to the dipole and cross the electric field. So the formula for the electric field that we're going to use is going to be the following: 1/4 pi epsilon naught r cubed 3 times p dotted with r hat minus p. So in terms of notation, I'm going to say that the electric field at this point 2, due to 1, that's just the notation that I want to say, that I want to use, is going to be equal to 1/4 pi epsilon naught r cubed 3 times. So here I'm going to use the dipole moment, of the p at the center. So in this case, it's going to be P1. So Pz hat dotted with r hat, and then r hat minus Pz hat. So now comes something very important. We need to see what the angles are. Since we're dealing with spherical coordinates, because we have this r hat, we're dealing with spherical coordinates. So let's remember what they are. If we have a vector that goes like this, then the angle between the vector and the z direction is going to be called theta. And this projection onto the xy plane, the angle between the vector and the x direction, that's going to be called phi. As you can see, in our case, the r vector is directly on top of the y axis. That means that the angle, this theta, is going to be pi/2, and so will phi. Phi is going to be pi/2 as well. So let's keep that in mind. So in order to do Pz hat, r hat, we need to look up the back of our book, and we see that the z component of the r hat direction is just cosine theta. So this is going to become 1/4 pi epsilon naught r cubed 3 times p cosine theta r hat minus Pz hat. But theta is pi/2, and cosine of pi/2 is 0. So this term goes to 0. And that tells us that the electric field at the location 2 due to 1 is equal to just 1/4 pi epsilon naught r cubed times minus p c hat. All right? So the electric field is going in that direction, in the downward direction. That makes sense? So let's calculate now for the other case. In the other case, we're going to put P2 at the center. So here's going to be P2, that is going that way. And therefore, I'm going to make, this is my X, this is my Z, and then, well, this is my Y, but I'm going to make it that way, negative Y direction, right? Because that's where my P1 is, okay? And it's pointing that way. So again, we look at the angles. So the angle, the R vector is directly on top of the Y-axis again. And the angle that it makes between the Z is going to be theta equals pi over 2 again. But now this angle is negative pi over 2. Okay. So let's write down the equation again for the electric field. So the electric field at 1 due to 2 is going to be equal to 1 over 4 pi epsilon naught r cubed 3 times p dot r hat minus p. But remember that in this case p is going to be equal to p2 y hat. Okay. Again, since we need to dot it with r, we look at our equations and we see that the y component of r is sine theta sine phi. So let's make that substitution, and we have 1 over 4 pi epsilon naught r cubed 3 times p2 sine theta sine phi r hat minus p2 y hat. So what's going on? Theta is pi over 2, so this one is 1, and phi is negative pi over 2, so that is negative 1. Yeah, it's negative 1, so this is negative 1. So this leaves me the following equation: 1 over 4 pi epsilon naught r cubed 3 times p2, well, positive times negative is negative, so minus p2 y hat. Oh, my bad, this is going to be r hat. But again, we look at r hat, and remember our angles are theta equals pi over 2 and phi equals negative pi over 2. So the x term goes to 0, the y term goes to negative 1, and the z term goes to 0. So we only have negative y hat. Negative y hat. So this one is equal to negative y hat. So our equation becomes 1 over 4 pi epsilon naught r cubed. Negative times negative is positive, so we have 3p2 y hat minus p2 y hat, which is just equal to 3 minus 1 is 2, so we have 2p2 y hat over 4 pi epsilon naught r cubed. You can simplify it if you want. Now that we have the electric field, now we can solve for the torque. So the torque at the location 1 due to 2, that would be, let's solve this one first. So the location at here due to this guy is going to be what? Is going to be equal to P1 cross the electric field at that point at the 1 due to 2. So let's quickly remember P1 goes in the z direction. So this is just P1 z hat cross E12. What is this one? It goes in the y direction. So that is 2p2 y hat 4 pi epsilon naught r cubed. Z cross y, let's figure out what that is. So we have x hat, y hat, and z hat. So we need to follow this order. So z cross y is going to be in that way. So it's going to be in the opposite, and that's gonna give us x hat. So in this case, negative x hat. So this is going to be equal to negative p1, p2, these two over here, 4 pi epsilon naught r cubed, x hat. That means that it's going into the page, right? That way over there is negative x. So it's going in that direction, into the page. Now let's find what is the torque at the position 2 due to 1, right? So what is the torque here due to this guy, all right? So same thing, P2 cross E21. P2, remember, is goes in the y direction. So this is going to be P2 y hat cross, and this one was, what was it? In the negative PZ hat. So it's going to be negative PC hat 4 pi epsilon naught r cubed. So again, y cross z, what is that going to be? Y cross z, that's going to be x, okay? But look, we have this negative. So that's going to be negative P2, P1, my bad, P1, x hat divided by 4 pi epsilon naught r cubed.